IESVE can be used to create a model for energy simulation based on the data extracted from the project documents for new or existing buildings. IES tools can also be used with the VE to calibrate a model of an existing building to improve the accuracy of forecast savings from retrofit interventions. The VE is an approved software for Singapore Green Mark compliance. It's capable of modeling the thermal performance of buildings in a multi-zone format. It can calculate the building's total energy consumption over a continuous 12-month period, and it offers more approved software solutions for compliance than any other vendor, including ASHRAE Standard 140, in line with BCA energy modeling requirements. The energy savings within the proposed model need to be validated within 2 years to achieve certification, with the revised energy model being used to compare the reference model with the actual energy consumption of the building once in operation. Steps to using IESVE for Green Mark assessments. Step 1. Project preparation and preliminary data setup. Step 2. Energy model development. Step 3. HVAC network development. Step 4. Generate calibrated baseline and proposed models. Step 5. Apply energy conservation measures. Step 6. Reporting and analysis. To get started in the VE, we need to create model geometry in Modelit based on the project design documentation. We can improve efficiency and save time by using the interoperability functions of the VE from 3D design software such as Revit or SketchUp using the pollination tool. Or the geometry could be based on DXFs of the project plans, but we'll quickly create simple demo geometry in the VE. We need to define the project location. This lets us apply site and weather data to simulate the local climate. The weather data that is included in the VE package can be used, or more files can be sourced through the IES webpage, or from measured data that is correctly formatted. Once this has been applied, the selected weather file and the associated ASHRAE climate zone will show at the bottom of the screen. The building constructions are very important in controlling heat gain from the external environment. We use the Building Template Manager, or BTM, for much of our data management within IESVE. If we look at the construction template, it contains all the construction materials used across all construction types. We can import from the library, edit, or create new constructions. Any constructions highlighted in green are currently applied somewhere in the project model. Once we've set constructions, we can apply them to the model geometry at model, space, or surface level. Remember that constructions may need to be set separately for the proposed and the baseline buildings. We can also use the BTM to look at the thermal template for both the proposed and the baseline buildings. ASHRAE templates are available to import as a time-saving option, which we can then edit further to suit, or we can create templates from scratch. We create templates for each space, which include the building systems or HVAC, and the space thermal conditions, controlling the temperature and humidity. Some aspects are usually linked to the building type, such as the internal gains or loads, including lighting, equipment, appliances, and occupancy. The schedules for each gain are assigned to them as profiles. External factors such as infiltration are also included. Templates can then be assigned across the whole model, or by space group, or to individual rooms, depending on the project. Using tabular space data lets us view the settings across any selected space or all spaces to check template assignment and differences between rooms. The SunCast application can be used at any time. It references the geometry and assigned location for a solar shading analysis. We can view the results of the calculations, which can be applied to a simulation to incorporate the impact of solar shading and solar gains. Or we can perform a solar energy analysis and view the results displayed directly on our model geometry. ApacheHVAC can be used for detailed and flexible HVAC system design. It helps to first create space groups, which we use as zones, to represent different space types or activities in the building. Then, we can use the HVAC wizard to quickly import a typical system and guide us through the steps to edit it to suit. Or we can simply import one of the many baseline systems available in the library. We can also import predefined settings from the library as we work, for example, the chiller performance curves. The HVAC system is laid out graphically with component parts and controllers, which can all be customized to suit. The systems are then linked back to the spaces and zones of the model geometry. We can edit the system parameters with reference to ASHRAE standards, such as occupancy classes. If we save this as the proposed HVAC system, we can then run ASHRAE loads to check the system auto-sizing against the design values, and then go back into ApacheHVAC to make changes if we want to. This gives us flexibility in how best to optimize the building HVAC for operational efficiency. For buildings that incorporate natural ventilation, we can also use MacroFlow to incorporate these strategies. We use ApacheSim to perform an annual dynamic energy simulation that incorporates all the inputs for this proposed design. We can choose what aspects we wish to include in the simulation analysis. They're all linked through the single central geometry model, which helps to facilitate design team collaboration. This simulation can be for a proposed new building, or a calibrated model, or an existing building that is being improved. On completion, we can view the results in VistaPro. Now, we are ready to generate calibrated baseline and proposed models. We repeat the process and adjust as needed to create the baseline design. Once we have 2 or more simulations complete, we use VistaPro to view the simulation results and compare the variables individually or collectively. Comparisons of simulation results can be made after every change and at every step of the project, from conceptual design onwards. For example, the difference in energy consumption across a full year. For existing buildings, we can also calculate NMBE and CVRMSE as part of ASHRAE 140 to check that our model has been properly calibrated by comparing the simulated energy to the actual metered energy use. There are also options to export general results using predefined reports, or to review building-specific detailed results as images, graphs, or tabular data. In summary, we're able to evaluate ECMs collectively, as the total impact may be greater than the sum of the parts, so we reduce the need to rely on overly conservative assumptions. To save time and increase productivity, the simulation process can be automated to run multiple simulations with different geometry or data attributes as proposed models. The VE also includes a parametric tool, which makes it quick and easy to undertake an iterative process for design improvement scenarios and the assessment of different ECM combinations. Accurate decision-making lets us confidently justify innovative strategies for energy savings. The IESVE facilitates baseline versus proposed comparisons. We can implement value engineering and use reports or tables, graphs, and charts to clearly demonstrate energy improvements and secure the targeted points for our Green Mark project. Thank you.